Hello everyone, my name is Sarah Ogle from Team 3, and today, along with my teammates Chris Burke and Philip Hoy, we are excited to present our case study for the course on smart manufacturing and global supply chain management under Professor Kyler Blowers. Our focus for this study is on Polywood industry, highlighting the integration of smart systems to enhance their manufacturing process. Let's start with a brief introduction to Polywood Industries. This company is at the forefront of eco-friendly outdoor furniture manufacturing. They primarily use recycled plastics, such as milk jugs, to produce durable, weather-resistant furniture. This not only reduces waste, but also minimizes the environmental impact compared to traditional manufacturing methods. Despite their strong mission in sustainability, Polywood faces certain operational challenges that we aim to address through smart manufacturing solutions. Polywood's current operations shows a significant gap in real-time monitoring, which is crucial for critical metrics like energy consumption and production efficiency. This lack of detailed data leads to higher operational costs, inefficiencies, and ultimately wasted materials. Our proposed solution focuses on leveraging smart technologies to provide actionable data. This will enable Polywood to optimize their production processes and reduce waste, thereby improving their overall efficiency and profitability.
So now that we've identified what's wrong with Polywood, let's talk about how we can fix it. Some things we want to do is implement Amazon Web Service. They have some software packages we'd like to put Polywood on. What we have determined is that we'd like to get Amazon Web Services database, their Internet of Things collection software, and their open source analytics software. This will allow us to not just store and collect data, but also analyze it and look at it over longer periods of time. We'd also like to install sensors from Rockwell Automation and Allen Bradley. Currently, Polywood operates at the operational level. Implementing these sensors instead of the ones they currently have will allow us to gather data and project it and see what it looks like longer than just the amount of time that it takes for the machine to decide what it needs to do. So this will be crucial to making the system more efficient. It'll be crucial for looking at machine health, and it'll also help us decrease energy costs. Okay, so now that we've talked about what we want to do, let's talk about how feasible it actually is. So we want to get roughly 50 new sensors, some to replace the old ones, a couple new ones to put in the system. Sensors cost about $100 each, and the controllers that'll be used in order to gather the data from the sensors, they're about $100 to $200 each. So we're going to estimate about $15,000 in hardware. And more importantly, let's consider the fact that Polywood will be paying $3,500 every single month in software packages with Amazon Web Services. That equates to about $42,000 every year. So we're talking a pretty decent amount of money. So how can we justify investing all this money? Well, when doing some research, it seems like energy savings is a good way to go because it's relatively consistent. So we did some research. Articles say that when companies implement Internet of Things technology, typically they save 10 to 40% on their energy bills. So if we use a relatively conservative estimate of 20% energy savings for Polywood, we take into consideration that Polywood, we're going to assume, produces 20 chairs every single day. This equates to 550 pounds of plastic. And in order to produce 1 ton of recycled plastic, you have to input 11,488 kilowatt hours of energy. Let's also take the fact that Indiana's energy rates are roughly 12 cents per kilowatt hour. So we take all of this information and we determine that Polywood annually will save about $27,500 in the recycling process alone. So this is not taking into consideration their manufacturing process or their assembly. So because they're saving $27,500 in recycling, we think that it's reasonable that they will also save $15,000 across the rest of their process, which will offset the payment that they're making to Amazon Web Services and the initial hardware investment. This is energy savings alone. It's much more challenging to know how much Polywood will save on, for example, their efficiency with these Internet of Things devices, or how they can reduce downtime to further increase their profits. But this is a good estimate in order to prove that this is a good investment for Polywood.
The project timeline will be divided into 4 main phases. The first phase will be about a month long and will include defining a parts list for the productivity and efficiency analysis. It'll include all the existing hardware and any new hardware that might be required. The procurement phase will be approximately 1 to 2 months long, and it will involve procuring parts and setting up the AWS services, integration, and implementation of the AWS functions. The third phase will be the install phase, and this will include systems setup, integration, and all of the installation activities. The fourth phase will be approximately 1 to 2 months long and will be a period of time for data collection that will be used for calibrating the systems, as well as providing a baseline data set for the environment. Once all of these phases are complete, a baseline data set will be available to be analyzed, and changes can start to be made to the operations for increased efficiency and productivity. Our assessment of the Polywood operations identified potential inefficiencies in the recycling, extrusion, as well as assembly processes. Real-time data is needed to accurately measure the resources consumed, waste generated, as well as time and energy spent in these areas to truly optimize the system for efficiency and productivity. Smart manufacturing solutions will address these needs and improve the overall performance, sustainability, and profitability at Polywood. Strategic enhancements at the Polywood Industries will come in the form of efficiency upgrades, waste reduction, and energy savings. Real-time tracking of machine performance and power usage will optimize processes. Monitoring the material flow and byproduct generation will reduce waste. And smart system tuning to minimize energy consumption during off-peak hours will reduce energy consumption. In conclusion, these proposed improvements have a significant capacity to enhance Polywood's operational efficiency, reduce waste, and increase profitability. The smart manufacturing upgrades that we've discussed align with industry best practices and position Polywood as a leader in sustainable production. Polywood should proceed with these investments to capitalize on long-term savings and competitive advantages.